Today we're going to look at section 9.3, arithmetic sequences and series. And after this lesson, you should be able to find the indicated nth term of an arithmetic sequence and also find the sum of an arithmetic series. We mentioned last time that an arithmetic sequence is a sequence where the first difference, called the common difference, marked by a D, between each successive term is constant. So every two terms are going to have the same difference between them. For example, here I've got -4 to 1. The difference is 5. From 1 to 6 is 5. From 6 to 11 is 5. From 11 to 16 is 5. So the difference D is equal to 5. Let's take a look at this one here. 7, 13, 19, 25. 7 to 13 is 6, 13 to 19 is 6, 19 to 25 is 6. So yes, there is a common difference of 6, and we'll mark that with a D. D is equal to 6. Here I've got -8 to -4 is 4, but from -4 to 0 is 6, and then 0 to 6 is 6. So even though these are all 6, the first one is 4. So no, that is not common difference. It changes. It cannot change. All right. The rule for arithmetic sequences is n sub a sub n is equal to a sub 1 plus n minus 1 times d. If you think about it, if we start with the first term, a sub 1, and add up n minus 1 differences, that will take us to the nth element. So again, a sub 1 is the first term, n is the general term, the term that you want, and d is the common difference. So write an arithmetic sequence with the first term 5 and a common difference of 2. So that's a sub n is equal to my a sub 1, which is 5, plus n minus 1 times my difference 2. Now I can rewrite that and combine like terms and finish up with a sub n is equal to 2n plus 3. And so for n is equal to 1, 1 times 2 is 2 plus 3 is 5. And we could do that for any n. Well, let's look at number 2. Write a rule for the nth term of the sequence and then find a sub 15. Well, here it looks like my difference is 3. I'm sorry, -3 because we're going down. And my a sub 1 is equal to -7. So if my d is -3 and my a sub 1 is -7, then I could write this as a sub n is equal to a sub 1, which is -7, plus n minus 1 times d, which is -3. And I could rewrite this and combine like terms. A sub n is equal to -3n minus 4. And then a sub 15 then would be equal to -3 times n, which is 15, minus 4, and that turns out to be -49. Now, for b, my a sub 1 is 59. My difference between each of these is 9. So what do I have? I have a sub n is equal to a sub 1, which is 59, plus n minus 1 times d. Rewrite and combine like terms. I've got a sub n is equal to 9n plus 50. Well, what's a sub 15 then? A sub 15 is equal to 9 times 15 plus 50. That turns out to be 185. So I'll give you a couple seconds to jot that down. All right, let's take a look at writing a rule given two terms and not necessarily having a sub 1. But I can figure it out. How can I do that? Well, I know what a sub 8 is, and I know that a sub 1 plus 8 minus 1, because my n is 8, times d I can figure out that a sub 1 plus 7d is equal to 21. I still don't know what a sub 1 is, and I don't know what d is, but I can repeat the process with my a sub 27. A sub 27 is a sub 1 plus 27 minus 1 times d equals a sub 1 plus 26d is equal to 97. Now what I can do is I can subtract the first equation from the second equation. The a sub 1's cancel out. 26d minus 7d is 19d is equal to 76, and d is equal to 4. So now I know what d is. My d is 4. I need to figure out what a sub 1 is. I can do it this way. Going back to this first equation, a sub 1 is going to be equal to 21 minus 7d. Plug in 4 for d, and it turns out to be 21 minus 28. A sub 1, it's a little messy there, but it's a sub 1 is equal to negative 7. So a sub n is equal to a sub 1, which is negative 7, plus n minus 1 times d, which is 4. And I could rewrite that. A sub n is equal to 4n minus 11. Give you a second to jot that down. All right, there is another way to do it. And we'll do it on this side of the page. If I look at my y values or my range values here, I've got 97 and 21. My x values or my domain is 27 and 8. Now I know from my geometry days that slope is equal to rise over run. My rise is my change in y values or my change in the range. So 97 minus 21 divided by my change in x, which is 27 minus 8, is equal to 76 divided by 19. And that is also equal to 4. So now I can figure out d that way. Now I know what d is. I can plug it into this equation here where a sub n is equal to a sub 1 plus 4n minus 4, because my d is 4. I know what a sub 8 is. That's equal to 21. So a sub 1 plus 4 times n, which is 8, minus 4 is equal to 21. And I can figure out that a sub 1 is equal to negative 7. Well, now that I know what a sub 1 is equal to, I can write it using this equation again. A sub n is equal to negative 7 plus 4n minus 4, or a sub n is equal to 4n minus 11, which is exactly what we found over here. So 2 ways to do the same sort of thing. So I'll give you a second to jot those notes down. And as always, you can come back to these notes or take a screenshot or whatever you need to do. All right, so for an arithmetic sequence, we have a common difference, d, of negative 5. So we know what d is, and we know the 77th term, a sub 77, is negative 383, and we're asked to find the 39th term. So how could we do that? Well, instead of just going down the line one by one, which would take a long time, we could do it this way. First of all, I know that a sub n is equal to a sub 1 plus n minus 1d. Well, I don't know what a sub 1 is, but I do know what d is. And I do know what a sub 77 is. So I can rewrite this as, or plug in a sub 77 is equal to a sub 1 plus 77 minus 1 times negative 5. Well, and I know that a sub 77 is equal to negative 383. And I can solve for a sub 1, and it turns out to be equal to negative 3. So a sub 1 is equal to negative 3. Now I can take that information and figure out what the 39th term is because I know what a sub 1 is, And I know what the difference D is. My difference D is -5. I know that my a sub 1 is -3. So a sub n is equal to -3 plus n minus 1 times -5. And if I plug that in, a sub 39 is equal to -3 plus 39 minus 1 times -5, and do a little math, and it turns out to be -193. Right, we'll continue on. Now here, this guy down here is a mathematician by the name of Carl Gauss, who figured out some of this stuff. If I take two series, remember a series is the sum of the sequence. So sequence is just a list of numbers. The sum is adding up all those numbers. So if I take two arithmetic series, I take one, the same exact series, but I'm going to do one from the first element to the last. So a sub 1, I'm going to add a sub 1 plus d. So that's my second element, plus a sub 1 plus 2d. That's my second element, and so on all the way up to a sub n, my last element. Now I'm going to do the same thing, except I'm going to do it in reverse order. So I'm going to take the highest element, a sub n. Now I'm going to take the second to last element, plus a sub n minus d, a sub n minus 2d, all the way down to my first element, a sub 1. So I've got the same exact series, but I just wrote one lowest to highest and one from highest to lowest. Well, if I add them both together, look what I get. I've got 2 of the sum equal to a sub 1 plus a sub n. Here my d's cancel out, so I have a sub 1 plus a sub n. Here my two d's cancel out, so I have a sub 1 plus a sub n. All the way up to the last term here, a sub n plus a sub 1. And if you figure it out, I have to do it 1, 2, 3, 4, 5, 6, 7, all the way up to n times. Okay, so I've got twice the sum is equal to n times a sub 1 plus a sub n. Divide both sides by 2, and I can rewrite it either way. Okay. So we're going to use this to help us figure out what a sum is equal to. So let's take a look at this one. Find the sum of the first n terms of an arithmetic sequence. Compute the sums below. Assume that the terms in the first sum are consecutive terms of an arithmetic sequence. So for A, I've got 9 plus 12 plus 15 plus something, 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 all the way up to plus 366. I want to find what that is equal to. Well, I'm going to have to do a little bit of work. I know what my a sub 1 is, and I know what my difference is. My difference is 3. And I can use this formula once I figure out what my a sub, what n is equal to. I don't know what n is equal to yet. So how can I figure that out? Well, a sub n I know is 366. A sub 1 I know is 9, and I know my difference d is 3. So a sub n is equal to a sub 1 plus n minus 1 times d. Plugging in these values and combining like terms, I come up with 360 is equal to 3n, or n is equal to 120. So 366 is my 120th term. So a sub 120 is equal to 366. Now I can use this formula to figure out what the sum of that series is equal to. So my n is 120. My a sub 1 is 9. My a sub n, my a sub 120 is 366. If I add that up and calculate it, it turns out to be 22,500. So that's a lot easier than adding these all up individually. All right, well, let's take the sigma notation here and figure out what this sum is equal to. Well, what do I have? My 1, I'm going to plug it in for k. My 149, I'm going to plug it in for k and figure out what those two values are. So a sub 1 is going to be 4 times 1 minus 12 is equal to negative 8. So I know what my a sub 1 is. My a sub 149 is 4 times 149 minus 12 is equal to 584. I don't care what d is because I don't need it for this equation. Right? All I have to do is plug these values into this equation, and I don't care what d is. So my n is my upper index, 149. My a sub 1 is negative 8, which we found here. My a sub 149 is 584, which we found here. Divided by 2, multiply it together, come up with 42,912. Now this one you could check on your calculator if you wanted to, and it should work out. All right, you might get something like this on a standardized test, a PSAT or SAT test someday. It says write the sum of the arithmetic series. Well, I know that my lower index is 1, my upper index is 20. So my a sub 1 is going to be 3 times 5. 3 plus 5 times 1, so that's 8. My upper index is 20, so 3 plus 5 times 20 is 103. Plug it into the equation from the previous slide there, and this is going to equal 20, which is my n, times a sub 1 plus a sub n divided by 2, and it turns out to be 1,110. So the answer is C. All right, here is a real life example. So the center section of a concert hall has 15 seats in the first row. So A sub 1 is going to be equal to 15. And 2 additional seats in each subsequent row. So D is going to equal 2. How many seats are in the 20th row? So A sub 20. And if the concert hall is 35 rows deep, how many total seats are there in all? So going back to the beginning here, a sub n is equal to a sub 1 plus n minus 1d, so that's not too hard. So a sub 1 is 15, my d is 2. I could rewrite this as a sub n is equal to 2n plus 13, and a sub 20, 2 times 20 plus 13 would equal 53 seats. Now, if the concert hall is 35 rows deep, how many total seats are there? So we're going to do a summation here. So I know I want to find that. Oh, that's a little. I'm going to get there. Sorry. So S sub n is equal to n times a plus 1 plus a plus 2 divided by 2. S35. So I could have figured out that a sub 35 is equal to 83. I should have shown that for you here. But if S sub 35, so the sum is going to be n, which is 35, times 15, which is a sub 1, plus a sub n, which is 83, divided by 2, it turns out to be 1715 seats. So to have found this a sub 35, we would have had to do this same sort of thing where it's 2 times 35, which would be 70, plus 13 would be 83 seats in the 35th row. All right, and that's all we're going to do for today. Here is your homework listed, and here's some Alex suggestions. So I will stop here.